So this is our next screen. So we have seen how the potential for single electrode is determined. Okay. Now next part that we have to see, that is types of electrodes. We have seen to construct cell we need two electrodes. One is anode, other is cathode. Okay. Again, in determination of single electrode potential, we have seen one is the reference electrode whose potential is constant, that we have to choose, and other electrode whose potential we have to determine. Okay. So reference electrode and the other electrode whose potential we have to determine. Now this other electrode, that is based on these basic 5 types. Okay. So there are basic 5 types of electrodes. One, that is metal ion electrode. Second, that is amalgam electrode. Third, metal insoluble salt electrode. Fourth, gas electrode. And the fifth one, that is oxidation reduction electrode. Now metal ion electrode, from the name itself, what we can say? Metal in contact with metal ion. Then amalgam, that is the mixture of metal with small amount of mercury, that is amalgam electrode. Okay. Metal insoluble salt electrode, that is metal in contact with insoluble salt and solution. Gas electrode, gas in contact with solution. And the oxidation reduction electrode, that is a solution which has ions in 2 different oxidation states, that is oxidation reduction electrode. So while observing in detail, we'll see this, how these are constructed. So first, metal ion electrode. Okay. Now how the metal ion electrode is constructed, that is we are writing it as construction of electrode. Metal in the form of rod or wire is dipped in solution of its ion. Means what we have to do? Metal rod किंवा metal foil किंवा metal sheet घ्यायचं आपल्याला, and that we have to dip into its ion solution. म्हणजे समजा आपण झिंक रॉड घेतला तर आपल्याला त्याला डीप करायला हवंय झिंक सल्फेट सोल्युशन मध्ये किंवा झिंक क्लोराइड सोल्युशन मध्ये किंवा झिंक नायट्रेट सोल्युशन मध्ये. ओके. सो दॅट इज मेटल in contact with its metal ion. Now we have to see these electrodes in a fixed format, that is how this electrode is represented, that is we have to say representation of electrode. Then from that representation we have to write its electrode reaction, or it is also called as half cell reaction. From that we have to write the EMF equation, that is the Nernst equation which we have seen. So from the reaction we can write that. Okay. So we'll see representation of electrode. So when we have to represent the electrode, the convention which we are going to fix here, that is the reduction convention. Okay. So keep that in mind when we are representing the electrode, reduction convention we are using. So this is the representation. N plus, that means metal ion. So it is in the form of a solution. So in bracket we have written here aqueous. Then the single line, that is our phase boundary. Okay. And then the metal in solid state. Okay, so that is how we have to represent the electrode. Metal ion, it is in the form of solution, so aqueous we have to mention in bracket. Then single vertical line, and then the metal in solid state. Now from this representation, the electrode reaction, or it is half cell. Okay. When we talk about cell, it consists of two electrodes. So half part we can call it as a single electrode, or that is called as half cell. Okay. So that's why electrode or half cell reaction. So the reaction is N plus, that means metal ion, plus N e raised to minus, I have written here. Okay, that means the number of electrons. So when metal ion accepts electron, it gets converted into solid metal. That is the reaction here. Okay. Then from this reaction, we have to write the EMF equation. So the equation is fixed. Only the reaction quotient is going to change. Okay. So E metal is equal to E0 metal minus 2.303 RT by NF log of QA. That is our reaction quotient. Now what is this reaction quotient in this reaction? It is QA is equal to activity of metal by activity of metal ion. That is, the right hand part, it is coming to denominator, and the left hand part, that is coming to, okay, this is numerator, the right hand part, and to the denominator, the left hand part is coming. So keep this in mind. That is, the numerator, it's a right hand part of the reaction, and the denominator, the left hand part of the reaction. Okay. And if you substitute this QA in equation 1, our equation becomes E metal is equal to E0 metal minus 2.303 RT by NF log of activity of metal by activity of ion. Then next, activity of metal in solid state is equal to 1. That is, it is the activity of pure metal, and it is fixed that activities of pure metals, pure solids, pure liquids or pure salts are always considered as unity. Okay. So whenever we have to write the activity of pure substances, that is metals, solids, liquids or salts, then it is 1. Okay. So our equation becomes E metal is equal to E0 metal minus this part as it is. This activity of metal becomes 1. So we are having this. Then by changing this minus sign to plus. Okay. So this we can change to just activity of metal ion. Okay. So this is the equation, that is E metal is equal to E0 metal plus 0.0591 by 2 log to the base 10 activity of metal ion, and this is the reduction potential of the metal ion electrode, or we can call this as the Nernst equation for the electrode potential of metal ion electrode. Okay. Now at 25 degrees centigrade, that is at 298 Kelvin, the value of 2.303 RT by NF, it becomes 0.0591. You have seen how it is coming. So our equation 4 becomes E metal is equal to E0 metal plus 0.0591 by N number of electrons into log to the base 10 activity of metal ion. So this equation 5 we can use to determine the electrode potential of metal ion electrode. Okay. So these are the examples which we can consider as metal ion electrode. First, that is zinc electrode, that is Zn ions in contact with zinc solid. Copper electrode, copper ions in contact with copper. Silver electrode, silver ions in contact with silver solid. Aluminium ions in contact with solid aluminium, lead ions in contact with solid lead. So here I have written the number of electrons. Those are included in case of these electrodes. Then just example of zinc I have given here. Okay. And the remaining examples you are going to solve. You have to try it at home by observing this one. Okay. So zinc ions in contact with zinc metal. Then the reaction is Zn2 plus ion plus 2 electrons gives zinc solid. Okay. Then this is the representation how we have to do. Okay. So EZn, that is at the bottom, the name of the electrode we have to write. Okay. Then E0Zn, remaining part is same. Then as per our this reaction, we have to write the reaction quotient. Here the reaction quotient. Okay. Activity of zinc divided by activity of zinc ion. Okay. That is right hand part we have written to numerator, left hand part to the denominator. Then by substituting this, then activity of Zn, it is 1 because it's a pure metal. This equation becomes okay. Then by changing this minus sign, 2 plus, this is our equation. Then at 298 Kelvin, this value becomes 0.0591. So here we have changed this 2, that is N is number of electrons. So this is the equation we can use to determine the electrode potential of zinc. That is when E0Zn, that is